These are video notes for 3B, and the title is Domain of a Function. The domain of a function is, you can think of it as all the possible inputs of a function. Or another way of thinking of that is all the possible values for the variable. So let's say we have the function f of n is equal to 3n plus 5. And so when you're trying to think of what the domain is for this function, you have to think of what are all the possible values that n could be. What are all the possible numbers that I can input in for n or substitute in for n and still make this function work. And so the bank of numbers that you can choose from, you can think of them as being, so can n be positive? Can n be negative? Can it be a decimal or a fraction? Right? Or can n be an integer? Right? Integers are whole numbers. Whole numbers. So whenever you're trying to figure out what the domain of a function is, just ask yourself for this variable, right? Can it be positive? Can it be negative? Can it be decimals or a fraction? Can it be integers? And what n can be is going to depend on the type of situations you have. So we're going to use this same function but in 3 different situations. So let's split this second half of our paper into thirds. So let's do a line about here and another line about here. And let's say our first situation, so I'm just going to say situation 1, it's the equation only. Well, if it's just the equation only, so for positive numbers, right, you could definitely do like any positive number, like f of 7. That would just be 3 times 7 plus 5. That works. So we can have positive numbers. Can we have negative numbers? Well, if you had f of negative 10, for example, you could do 3 times negative 10 plus 5. That works. So negative numbers work. What about if you have decimals or fractions? You ask yourself, well, can I evaluate the function for f of like 2.7? Sure, because then it would just be 3 times 2.7 plus 5, and I can evaluate that, so that works too. And then obviously integers and whole numbers also work. I can plug in any whole number, positive or negative. So then that's why, if it's just this equation right here, I can say that the domain is equal to all numbers. Because they can be positive, they can be negative, they can be decimals, they can be whole numbers. Any number works for n, substituting it in and evaluating for this function. Another situation, situation 2, and let's use one of our previous examples. Let's say it's that you have traveled 5 miles and now you're walking 3 miles every hour. So if we do the same kind of thinking, well, if this is our function, and this represents how many miles we traveled, and n is going to be the number of hours, you can have positive numbers, right? Because positive hours. Now, can we have a negative value for n? In this situation, we cannot. So, because, right, you can't have negative hours. And then let's also check if decimals or fractions work. So I'll just put decimals. Can I have 2.5 hours? Can I have 3.6 hours? You can. So you can have decimals for n in this function for this situation because, right, you can have, for example, 0.8 hours. So in this case, positive numbers work, negative numbers don't, decimals work, and then we also know that positive whole numbers work too. So for this situation, our domain is all positive numbers. Okay, last situation, situation 3. And it's my favorite trick-or-treating example. So we'll say Bella has 5 candies and she receives 3 each house. So we can go through the same thing. Positive numbers. Yep, right. Positive is the number of houses. So in this case, like n equals houses. So she can have a positive number of houses. Can she have negative numbers? No, she can't have negative value for n because you can't have negative houses. Then let's check decimals. Can she visit a decimal number of houses, right? Can she visit 2.5 houses, or 3 1/3 houses, or 102/5 houses? Well, no, you can't, because either it's a whole house or no house at all when you're trick-or-treating. So we can't do decimals. So you can say, right, you can't have partial houses. Partial houses. So in this situation, we can only have positive numbers, not negative numbers, and only integers or whole numbers because we can't have decimal or fractions of a house in this situation. So then that's why our domain in this third situation is all positive, not negatives, and we're going to say integers. Because integers means whole numbers. So it's all positive whole numbers, or the best way to say that is all positive integers. So what we've done here is we've taken this same function for three different situations, right? 3n plus 5, but depending on what the situation is and what the value for n means, the domain, right, the possible values for n changes. If it's just the equation, it was all numbers. In this situation, it was all positive numbers, and in this third situation, it was all positive integers.